Okay, unit 7 is when we graph trig functions. And again, you didn't have to know the triangles in between. You kind of need to know the major side angles to help us understand why trig functions just go up and then down and then repeat. You know, if you keep going around your circle, your ratios are going to start to repeat. And the maximum value, let's say for sine, will be when the vertical displacement is the maximum. The minimum value is when the vertical displacement is a minimum. We combine that knowledge with our knowledge of transformations, understanding that is a vertical dilation. This is a horizontal dilation by a factor of 1 over b. This is a horizontal translation. This is a vertical translation. 2, understand that if we are adjusting things with a trig function, that the following occurs. Because it takes 2 pi radians to start repeating itself, we have what's called a period. A period is a length in which the graph goes through one cycle. Okay, so like it is the x distance for one cycle, or it's like the time per one cycle. So that's important. Time per cycle is important. Since that is typically 2 pi, what happens if we adjust b is that we will adjust horizontally how long it takes for our things to repeat. So this affects the period. B affects the period because P is a horizontal dilation. Horizontal, like what are the angles where we're going to start repeating. So we will horizontally dilate the normal parent function sine x by taking its period 2 pi and dividing it by b. We understand C being a horizontal translation is going to affect the beginning, like the start. We call that a phase shift. We understand that a vertical dilation with a trig graph will affect the ups and downs. We call that an amplitude. A is going to affect an amplitude. And then D is going to be a vertical shift, just like we're kind of understanding things. So, like, if you understand this, you understand this. It's not extra stuff to remember with the fact that things start repeating at 2 pi, typically. Just come in tomorrow. Okay. So, some things, if you're given the graph, what's up? I'll pause. All right, so some things we notice is that we're going from a max of 4 to a minimum of -2. So that total distance is 6. If we divide it by 2, we'll get our amplitude, which is 3. We can see amplitudes are all 3, so that doesn't really help us. If we have this top of 4 and this bottom of -2, we can find the average of them to see the middle. So this will be at 1. So we could see that's the middle 1. We could see that vertical shift of 1. So these are all good things. Now, we could choose sine. Sine's parent function starts at 0, and then the sine of pi over 2 is 1. Then the sine of pi is 0. So you see one period of sine looks like that. Goes up first because sine's positive in the first quadrant, versus cosine. The cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. And we see one period of cosine looks like that. Okay, so if I were to choose A, I'd want this to be +3. It's not. If I want to shift over to the right pi, looking at pi, if I plugged in pi, okay, that works out. Like we have that point in the center. However, I would want -3 sine, so that's not right. If I shift over to 3 pi over 2, I can see I'm starting at a minimum. If this was -3 cosine, that would work out. So let's look at this one. Shift over to 5 pi over 2. Not necessary to do this, but this is just how like you have an infinite amount of graphs that it's going to that infinite amount of equations that are going to create that graph. But if I shift over to 5 pi over 2, if I plugged in 5 pi over 2, I'd get the cosine of 0, which is 1 times 3, boom. So this works. All right, this is the same thing. We got all of the amplitudes and the shifts correct. We just need to figure out the period. I could see from a max to a min, that's one way to find your period. You would double this. So I got 3 pi minus pi, which is 2 pi, doubled, which is 4 pi. So my period is 4 pi. Now the period is 2 pi divided by b, like horizontally dilated. You could find that the b value is going to be 2 pi over the period. If the period's 4 pi, I'll take 2 pi divided by 4 pi, and I get that b's got to be a half. So I'm looking for a half. Okay, so that's good. What's another thing to find your period? You could also say like from the middle to the middle. You can see that's 4 pi. So not from the middle to the middle. After going through your entire cycle, one period, boom, period's 4 pi. So b's a half. We either are going to shift over to 2 pi, and we see we go down, which is the graph of negative sign. Sign first goes up and then down, then up, because first quadrant is positive, the sine of pi over 2 is 1. This one's going to be a vertical reflection of that. All right, cool. So you don't have a calculator to do this. You're told this is the amount of daylight total at a certain day. And what you need to do is understand what's going on. This value is affecting the period. This value is affecting the amplitude, and this value is affecting my vertical shift, or my vertical shift. My midline, that's what it's called, midline. So if I wanted to graph this, your middle is going to be at 1150. You will add 325 to get 1475. That would be the maximum amount. The minimum amount you would subtract. So like that's wrong and that's wrong. Since it's the graph of cosine, we know we do start at a maximum. So if there's no phase shift, there is no phase shift. So at 0, the maximum is going to be there. And the maximum is 14.75. Okay, this is the same deal, but careful. We got a midline adjustment, a vertical translation of 5,200. I have an amplitude of 1,200, so this is going to go up to 6,400. And this will go down to 4,000. Okay. We have a phase shift of 2. I have a period, which is 2 pi over b. That's the same as 2 pi times 6 over pi, which is 12. So the period is a total of 12. If I want to step this out into quarters, my step size will be 3. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, which makes sense. 2 plus 12 is 14. We have a negative sign, so this would be the graph of one period, just like basically. Yoink. Maximum amount of deer is 6,400. Minimum amount of deer is 4,000. But if I went back 3 to -1, I would have that maximum. This is where it's tricky. You would say, oh, the max occurs at 0, but no, the max is going to occur at -1, not at 0. Great question, Pascal. He crushes. Great questions, man. All right, we're talking about tangent. What's the difference about tangent? Tangent's values are the same in the first and the third quadrants. If you have a pi over 6 and then this pi over 6, boom, you're going to get the same result because it's opposite over adjacent. So it's either a positive 1/2 over root 3 over 2, or it's a negative 1/2 over negative root 3 over 2. The tangent values in the second and the fourth are the same. So what we find is that tangent repeats in half of the time or half of the angle amount as sine or cosine. So the period of tangent is actually pi. Cool. What's some other values to remember? The tangent of pi over 2 and the tangent of 0. It's very good to do this if I'm at 0 and I'm talking about opposite over adjacent, y over x versus pi over 2, y over x.
Thank you.
Cool. Happy to go over any of those
Okay.
whenever you want. Yeah. And this is how we know what the graph of tangent looks like. If we go to pi, we're going to start repeating itself. But in between, at the pi over 2s, we're going to have these vertical asymptotes, like we talked about in the rational functions. We start at a 0, tangent's positive in the first quadrant, tangent's negative in the second quadrant, and boom, that's a period of tangent. And then it starts repeating itself, okay? So the period of tangent equals pi. If the period is 4, well, the period of tangent would be pi over b. That means b equals pi over the period of tangent. B equals pi over 4. Bam. Okay. Period of tangent is pi over b. So this period is 4 pi. Where are vertical asymptotes? Well, it would be every quarter of the step. Now it's funny, like when we do this, this is 4 pi here, which means this is going to be my asymptote half. Like we sketch out a full period of sine, which takes us from 0 to 2 pi. When we sketch out tangent, we just go half the way before we start repeating itself. So like here, we're going to go up, and then we're going to start repeating ourselves here. We'll see that every 2 pi, we're going to have these asymptotes. It's one way to do it. Or you could try to solve the equation, when does tangent of x over 4 equal either pi over 2 or 3 pi over 2. So the angles, equal undefined. Those angles are either pi over 2 or 3 pi over 2, and they're multiples. So that's pi over 2 plus pi n, multiples of pi. Those angles equal x over 4. I could multiply everything by 4, and I could see it'd be 2 pi plus 4 pi n. There's one way to do it kind of just solving. Here's one way to do it graphically. 2 pi plus 4 pi n. All right, I think I can finish this. All right, same deal. Let's do it. One is tangent of pi x undefined. Those are going to be pi over 2 plus pi n's. Divide by pi, I get 1/2 plus n. Probably easier than sketching the graph, understanding the period, and stepping it out. Now, this is tricky. It's either this one or this one. We didn't really get into this. So why am I having troubles with this? Because we got tangent pi x, which is a horizontal dilation by a factor of 1 over pi. It's affecting the period. Period's going to be 1. If we dilate first and then shift everything right, which is what we want to do, we get that. However, be careful because like if you distribute this out, you get that. This would be a translation first, then a dilation. Again, it's like, how do you invert this? If you have pi times x minus pi over 2, and you're trying to, solve for x, you would divide by pi first, then add pi over 2. That's the whole dilation by a factor, and then the translation to the right. Dilation by a factor of 1 over pi. If I had this, I would shift first, then dilate. We already have the dilation. Now we're shifting. That's the answer. I don't like we always in our class kept it dilate first, then translate. I haven't seen anything that flip flops, but there have been some questions where it's like, ooh, could be. No, it isn't. So, all right, I can see the period is 2 pi. It's where we start repeating ourselves. So the period of tangent is pi over b. So that means b is pi over the period of tangent. The period of tangent here is 2 pi. So that means b has to be a half. Where are my zeros? Up 1. A lot of tangents. Look at that. So many tangents. It's what it is. I'd be ready for sine and cosine too. All right, this is shifting to the right pi over 4. So this is where I'm going to think about starting. I can see that we're going in the opposite direction that tangent usually goes. So I'm thinking A is going to be negative. What's my period? Well, it takes me a total of pi over 2 if the period is pi over 2, B is 2. So B is bigger than 1. Which intervals is tangent concave down? I don't think we asked you this one. Concave up, concave down, concave up, concave down. Go back in time. Concave down. We're good. All right, it's Unit 7. Let's get ready for Unit 8.